All right, 4.2, adding and subtracting matrices. So matrix addition and subtraction can be done when matrices have the same dimension, right? Remember, the dimension is the rows by columns. To perform matrix addition, I'm right here, we add corresponding elements, the elements in the same position of each matrix. So if we look here at our example, if we look in the upper left corner, we have A and 1. Those are in the same spot. Our new one is A plus 1. And then we have B and 2, B plus 2, and so on. And that's how we would perform matrix addition. They have an additive identity. You add 0 to it. It's a matrix filled with zeros, and that's the same thing with regular numbers. Some people could describe the number 0 as the additive identity because you add 0 and you get the same thing. The additive inverse is the negative version of it. So like if we were thinking of regular numbers, the additive inverse of 5 would be negative 5, right? The additive, the matrix here, right here, matrix negative A is the inverse of A, right? Because if you add them up, you get 0, okay? Properties of matrix addition. If A, B, and C are m by n matrices, then A plus B is also an m by n matrix, right? We could think about if you add them together, you still get a matrix that's that same size. That's called being closed. A plus B is B plus A. They're commutative, just like what we've always known with numbers. They're associative. It doesn't matter what order they are added. Next up, there exists a unique. The backwards E there means there exists, and the exclamation point means a unique, right? Those are kind of like math lingo. There exists a unique matrix 0 such that A plus 0 equals A, right? And we already talked about that being the identity matrix, or the additive identity. And then there also exists a unique opposite matrix, such that A plus negative A gives us 0, and that's talking about our inverse, right? These are all rules that we know from regular addition. As we go on, whenever we get to like multiplication, it might be a little bit different. But this works for here. So let's scroll down and do some examples. A matrix equation, one last definition. A matrix equation is an equation where the variable is a matrix, right? Nothing crazy. So part A here. What is A plus B? Well, let's write this out. We'd have 1, 2, 3, 4, 5, 6 plus negative 10, 9, negative 8, 7, negative 6, 5. Right. When we put these together, we add corresponding parts, and I'm not actually going to do any of the addition in this step. I'm just going to write it out. So we'd have 1 minus 10, 2 plus 9, 3 minus 8, 4 plus 7, 5 minus 6, and 6 plus 5. Right? All I did there is I wrote them as the plus and the minus together, right? I had 1 minus 10, 1 minus 10. 2 plus 9, 2 plus 9, right? My final answer here gives me, what is that, negative 9, 11, negative 5, 11, negative 1, and another 11. A bunch of 11s. So this here is my answer. All right. Part B, we have A minus B. A is, what is A? It is 1, 2, 3, 4, 5, 6 minus B which is negative 10, 9, negative 8, 7, negative 6, and 5. Now, this works the same way as we would think about subtracting negative numbers like in real life, right? I'm going to have 1 minus negative 10, so it would really be 1 plus 10, right? 2 minus 9, 2 minus 9. 3 minus negative 8 will be 3 plus 8. 4 minus 7, 4 minus 7. 5 minus negative 6, 5 plus 6. And 6 minus 5 is 6 minus 5. Putting those together, I get 11, negative 7, 11, negative 3, another 11, and what is that, 1? Now, why is that? That's kind of neat. All right. Hopefully we're good on the addition and the subtraction. Here, I'll box this in again. There we are. All right. Lastly, we have a actual equation here. So a plus x equals b. And we're supposed to solve for x. And we also know here, because of the way this is written, x is a matrix, right? So we first can solve this for x, right? So I'm going to solve for x, and I'm going to say, well, x equals b minus a, right? Now I'm going to do some fancy algebra here so that we can be lazy. Well, you know what? I won't yet. B minus a, so x is going to be equal, and I'm just going to plug in here, and we'll just do it by hand. B is negative 10, 9, negative 8, 7, negative 6, and 5, minus, and a is 1, 2, 3, 4, 5, 6. Now here I'm not actually going to write the intermediate step. I'm just going to jump straight to the end. We got negative 10, that'll be a negative 11, 9, 8, 7, negative 8, 9, 10, 11, negative 11, 7 minus 4, 4, 5, 6, 7, that's 3. That'll be negative 11 again, and negative 1. And there we are, right? This is x, that's our matrix x, all right? So let me take a look at the homework and see if there's anything extra you guys need to know. The only last thing that I'm going to do here is going to be if I have a matrix with, like, we'll say A, B, C, D equals 1, 2, 3, and 4. If I have something like that and it tells you to solve for A, B, C, and D, you'd know that A is 1, B is 2, C is 3, and D is 4, right? Now, if it had something like a plus 2, you know that you'd say a plus 2 is 1, and you have to solve from there, right? So I think that'll be relatively easy for you guys. Again, as always, email me if you have any questions, let me know, and good luck on the homework.